So in this video we're going to find the set of odd primes for which 23 is a quadratic residue. Now as we're looking for odd primes, our prime numbers, our modulus 4, are going to take two forms. So if we let P represent our prime number, we've got P is congruent with 1 modulus 4, or we've got P is congruent with 3 modulus 4. That's the basis of our prime numbers. Now, for P to be congruent with 1 mod 4, using the Legendre symbol, what we have is we have P 23 equals 23 with P, which equals 1, i.e. that is a quadratic residue. Now, the other way we can look at the Legendre symbol with P congruent with 3 mod 4, the rules for the Legendre symbol are a little bit different. So what we have is here, we have 23 with P equals P with 23, but it's a minus sign here. And then this equals minus 1. So that would tell us in the Legendre symbol, 23P equals minus 1. P would then tell us that is not a quadratic residue. That's the resulting situation we've got here. Okay, so let's use this P is congruent with 1 modulus 4 and this Legendre symbol, which is telling us that we have our quadratic residues. So what we need is a solution to x squared is congruent with a modulus 23. So our set of prime numbers for that will give us P is congruent with, well, if we go through numbers from 1 to 11, that will give us our first half. And then the non-residues will be 12 to 23. So using 1, we've got 1 squared, 2 squared, all the way up to 11. And then we can simplify these off modulus 23. These will give us all our quadratic residues modulus 23. Okay, let's make these congruent to 23. So 1, 4, 9, 16. They're all in straight away. That's straightforward. Now these from here onwards we'll have to just simplify modulus 23. So 25 will give us 2, 36 will give us 13, 49 will give us 3, 64 will give us 18, 81 gives us 12, 100 gives us 8, and 121 gives us 6. So that's our quadratic residues modulus 23. But if we've introduced P is congruent with 1 modulus 4 as one of our rules, we now need to use the Chinese remainder theorem and use modulus 92 because we've got mod 23 and mod 4. So Chinese remainder theorem for modulus 92. What we now need to do is we need 23x is congruent with 1 modulus 4. So we need a solution for that first. That's going to be our multiplicative inverse. So for this, 1 is not going to work, so therefore 3 must work as we've got an odd number here. So 23 times 3 is 69. 69 is congruent with 1 mod 4. So now what we need to do now, all our P, all our prime numbers, so now P, what we need to do now is multiply that by 4 and add 23 times our solution to this, which gives us x is congruent with 3. So 23 times 3. So now we need P times 4 plus 69. Now that's our rule, what we need to do now for these using the Chinese remainder theorem. So now we've got P is congruent, going through all these, multiplying by 4 and adding 69. So 4 ones are 4 plus 69 is 73. 4 fours are 16 plus 69 is 85. 4 nines are 36 plus 69 is 105. So that gives me 13. 16 fours are 64 plus 69 is 133. So that's going to give me 41. 2 fours are 8. That's going to give me 77. 4 13s are 52. That's going to give me 121. So therefore mod 92, that's going to give me 29. 3 4s are 12, that's going to give me 81. and 4 18s are 72, 69, that's going to give me 141, that's going to give me 49, 48 plus 69 is 117, so that's going to give me 25, 64, 4 8 is 32, 69 is 101, so that's going to give me 9, and 6 4 is 24, plus 69 is 93, that's going to give me my 1. So that's my set of numbers modulus 92. So now what I need to do now is work with this one and solve that with the Chinese remainder theorem, and let's clear the board and let's work on that. Okay, so we've got all these up here now in numerical order. Mod 92, that's my result after the Chinese remainder theorem, and that's my original result with the quadratic residues modulus 23. So now we're working on p's congruent with 3 modulus 4. So here my Legendre symbol says -1. So that's all of the non-quadratic residues. So the non-quadratic residues were basically the numbers from 1 to 22, which are not in this set. So let's list those up. So now A, my set I need will be 5, 7, 10, 11. And then 14, 15, 17. And then 19, 20, 21 and 22. Okay, so now we need to apply the Chinese remainder theorem again on this set of numbers. So this time, p is congruent with 3 modulus 4. We need our multiplicative inverse, which is the solution to 23x is congruent with 3 modulus 4. So this time our x is going to be 1. So 23 is congruent with 3 mod 4. That's pretty straightforward to see. So now to adjust all these with the Chinese remainder theorem to get to mod 92, we need our p times 4, and then add 23 times our x, which is 1. So we just add 23. So times each of these by 4 and add 23. That'll be our new set of prime numbers. So let's go through them. 5 4s are 20, plus 23 is 43. 7 will give us 51, 10 will give us 63, and 11, that's going to give us 4 more, that's 67, and 4 14s are 56, plus 23 is 79, 60 plus 23 is 83, 68 plus 23 is 91, so that's the last one before we have to adjust modulus 92. So 19 4s are 76, plus 23 is 99, so that's going to give me 7. And then all of these are increased by 1, so we just need to keep on adding 4 until we get to this one. So the next 4, just keep adding 4. So we've got 11, 15 and 19. Okay, so that's our set P for our prime numbers modulus 92 here. So now what we need to do is to take these up to the top here and make a set of all our prime numbers modulus 92 to give our solution for odd primes for which 23 is a quadratic residue. So that is next. Let's clear the board. Okay, let's make our final set of prime numbers, which should have 22 solutions in there. So now we've got P is congruent, putting them in numerical order. So we've got 1, 7, 9, 11. Now the reason we're doing this, you'll see, because there's a way we can check our result at the end, which I'll show you when we've got them listed in numerical order. So we've got 1, 7, 9, 11, 13, 15, 19, and then we've got 25, 29, interestingly no numbers in the 30s, and then we've got 41, 43, 49. And I'm going to go all the way across, and then we've got only one in the 50s, which is 51, and then we've got 63, 67, and then in the 70s we've got 73, 77, 79, and then we've got 81, 83, 85, and then finally 91. And finally 91. And they just fit on the board just nicely. Now the way we can check this is by using the rules for quadratic residues. One of the properties is that our first one and our last one should add up to our modulus. So we've got 1 and 91. So take that one there, that one there. That gives us our first plus our 22nd should equal 92. Now it should be the same with our second plus our 21st. So adding these numbers up to 23 in position order, they should all be 92. So for example here, 7 and 85, that gives me 92. 9 and 83, 92. 81 and 11, 13 and 79, 15 and 77, 19 and 73, 25 and 67, 29 and 63, 41 and 51, and finally 43 and 49. So all of those pairs matched up should add up to 92. And that's one way you can check your table. Okay, so this is the answer to the set of odd primes which 23 is a quadratic residue. Okay.